Unit 6, Video 1, Graphing Quadratic Functions, and we're going to be doing this by hand and with a calculator, finding the axis of symmetry, vertex, and the zeros. Assuming it is already in standard form, which is ax squared plus bx plus c equals 0, we're going to follow the following steps. However, if it is not in standard form, we need to set it in standard form, so we need to get everything on the same side of the equation equal to 0. Step 1, find the vertex, which we've actually already done in this class. The x value of the vertex is called h. h equals negative b over 2a. And remember, we did that here in Unit 5 at the tail end when we were solving quadratic functions in the word problems. Then the y value of the vertex is called k. Find k by plugging your h value back into the equation, which we also did when we solved for the word problems. Step 2, the x or h value of the vertex is where you draw the line of symmetry. The axis of symmetry is simply where you could fold the graph and it would look exactly the same on both sides. This would be like when you drew the heart when you were in kindergarten and you figured out you could cut half of the heart and it would form a symmetric, pretty looking heart. You will draw a dotted line at the axis of symmetry. Step 3, find the zeros, or where the graph crosses the x-axis. We've been finding these in Unit 5 when we solved by factoring, quadratic formula, completing the square, or square roots. We replaced the y with a 0. We are setting the equation to where y equals 0 because that is where the graph crosses the x-axis. Step 4, now that you have the vertex and zeros, draw your parabola. So you're going to put a dot on the vertex, you're going to put a dot where the zeros are, and then you're going to draw a parabola. Make sure it looks more like a U than a V, because a V is technically absolute value. Extra information you need to know: if the value of A is positive, the parabola graphs like a smiley face, so it is going up. If the value of A is negative, the parabola graphs like a frown, so the lines at the end are going down. If the zeros are the same as the vertex or do not appear, you will need to find an additional point on each side of the vertex. And we're going to do a couple examples that show all these things. All right, example 1 says y equals x squared plus 7x plus 12. So step 1 we are going to do, which is finding your vertex, which is h equals negative b over 2a, and then plugging that into the value of the equation. Okay, so I went ahead and wrote the formula out. H equals negative b over 2a. You use this every single time to find the vertex, the x value of the vertex. And then I went ahead and wrote out that a equals 1, b equals 7, c equals 12. Again, I'm finding that from this information right here. So then now I am simply plugging it into that formula. So h equals negative 7 over 2 times 1. And I'm going to simplify it and probably throw it into a decimal in this case since it's a very pretty decimal. So we find that our h equals negative 7 over 2 or negative 3.5. So now I'm going to plug it back into that original equation at the top to find my y value so I have my complete vertex. Okay, so when I ran the numbers through, and it works either way, whether you keep it in fraction form or decimals, I end up with my y value of the vertex is negative 0.25 or negative 1/4. So my vertex is negative 3.5, comma, negative 0.25. My line of symmetry, where I'm going to draw that vertical dotted line, would be x. This is step 2. X equals negative 3.5. And yes, my line of symmetry is always the x value of my vertex. That's where I'm going to draw that vertical line. Now to find my zeros or my x-intercepts, I'm going to factor this. Again, you could use quadratic formula, completing the square, throwing it around and doing square rooting. It's not a good problem for that. Or factoring. I know that this is an easy problem to factor. And when I do, I get x plus 3, x plus 4. Again, it doesn't matter how you choose to get there. They all get there just in different paths. So I'm going to solve each one of these. So x plus 3 is equal to 0. And x plus 4 is equal to 0. So x equals negative 3. And x equals negative 4. Those are my two zeros. So now I'm ready to graph all this information on one graph. So my vertex is at negative 3.5, negative 0.25, which would be somewhere around there, that dot. I have a line of symmetry at negative 3.5 which to the best of your ability, draw a dotted line there. And then I have my zeros at -3 and -4. And then what I asked is for you to draw the best possible U-shaped graph you can. I know it's not easy. And you're drawing that looks like that. And you're drawing that looks like that. So there would be the graph of this equation if I did it by hand. Okay, so my first step is still going to be the same. I'm finding my vertex, so I'm going to be using those equations. Okay, so I have my h equals -b over 2a, and I start plugging things in. Notice my b value was a -16, so when I plugged it in there, I hit a -16, which gave me 16 over 4, which gave me 4. Now I'm going to find the y part of my vertex. So the y part of my vertex is 1. So my vertex is 4, 1. So that makes my axis of symmetry. That line that I'm going to draw is x equals 4. That's where the dotted line is going to go. So now I need to figure out my zeros. Well, I can tell that this does not factor because I can list up my factors of 66, 2 times 33. And I don't get any factors that equals a -16. So I'm going to choose to do it with quadratic formula. Okay, so when I run it through the quadratic formula, as I do all my math, I end up with x equals 16 plus or minus square root of -8 over 4. So this gives me the red flag. This means that there are no zeros. So there's nothing on the graph that crosses the x-axis. But you can still graph this. We're just going to have to find some new points. So to find these new points, since I know the vertex is 4, 1, my x value is 4, I'm going to pick a point to the left of 4 and a point to the right of 4. So I'm going to pick x is equal to 3 and x is equal to 5, and I'm going to plug these into the equation. Okay, so my first point, x equals 3, I plug that into the equation, as you can see here, and I end up with the answer of 3. So I know that there's a point on this graph that's at 3, 3. So now I need to do where x equals 5. Now, this often happens because we're talking about symmetry. When I plug in the 5, since I went the same amount to the left of that vertex of 4, going to 3, as I did the same amount to the right, so I went down 1 and I went up 1, I also get y equals 3 when I plug it in and do the math. Now, sometimes, if you're dealing with decimals, this will not be this pretty. But this is a very pretty problem. So now I know that I have 2 more points, and my 2 points that I'm going to plot are at 3, 3, and 5, 3. Those are going to serve as, since I don't have zeros, those are going to serve my extra points so that I can actually give a good graph of this. So let's graph. Okay, so first we're going to plot the vertex, which is 4, 1. Now I know from that extra information, since my a is a positive 2, this graph is going up. So now I'm going to graph my axis of symmetry, which is at x equals 4. And now I'm going to graph these other 2 points so I have an idea of how to draw my parabola. Making sure to draw it as a U and not a V. And there you have it. There is my parabola of this equation graphed on a graph by hand. All right, so here's the last example of this, y equals x squared plus 10x plus 25. And I'm going to run this a little bit faster, but making sure you see all the work as I go. Okay, so there runs the math for the vertex. The h equals -b over 2a. You get h equals -5. And y, you plug it through the equation, so you get the vertex of -5, 0. So my axis of symmetry is x equals -5. This problem actually factored really pretty to x plus 5 times x plus 5. So my 0, this is why my 0 lands on it. My 0 equals -5, which is my vertex. So I'm going to have to find 2 new points. All right, so I chose the points -6 and -4 because they were 1 away from -5 in both directions. And I got the new points -6, 1 and -4, 1. So let's graph this. So my vertex is at -5, 0. My line of symmetry is x equals -5. And my 2 points are -6, 1 and -4, 1. And my graph looks like a U, at least as best as I can make it. So there is the graph for the equation y equals x squared plus 10x plus 25.